Assalamualaikum warahmatullahi wabarakatuh. Today, I am presenting the paper's titled Feasibility Analysis of Using Wood Base for Boilers Fuel. It is the case study at PT Putra Al-Basyah Mandiri. The paper was written by Alvan Bahrul Alim, Insinyur Ekom of Widodo, Muhammad Imron Rosi DST, and me myself, Jusi Ari Purnomo, and also another one, Avan Rifai ST. It is presented for BIS, Borobudur International Symposium. So for not wasting the time any longer, it is the presentation. I will start with organization of writing. The first one is introduction, and then the second one is method. The third one is technical analysis. The fourth one is economical analysis. The fifth one is environmental analysis. The sixth one is result and discussion, and the last one is conclusion. For introduction, we know that seeing the potential volume of wood base, which is always increasing every day, in this case, wood base is used as a main fuel to power steam boilers. Wood base was chosen to be used as energy because wood base can be used directly for fuel without adding materials. Although on the other hand, the volume of wood base is increasing, the use of wood base can provide profits for companies. Utilizing waste as fuel in a solution for controlling waste resulting from the wood's processing. Using wood waste as fuel provides the advantage of not having to procure a fuel. The use of wood waste as fuel to be converted into heat energy using a boiler's engine can be analyzed from a technical perspective in the form of heat output from burning wood waste fuel and the volume of fuel required. While the financial aspect of the estimated cost that arise from investing in a boiler machine to utilize wood base and its relationship with the environment is related to amount of carbon pollution produced from burning fuel compared to using fuel other than wood base, for example, diesel fuel. The analysis will prove whether the use of wood base as boilers fuel is feasible. The methods. Research and data collection was carried out at PT Putra Al-Basyah Mandiri in the boiler section. The data in this research includes primary data and secondary data. Primary data is obtained from direct measurements in the field. Among the data required are boiler specification data, pressure and temperature data, and boiler operational data. Secondary data was obtained from literature and other supporting data. While the analysis of this research was carried out on the use of wood base as boiler fuel, the analysis was carried out from three aspects. First one is technical aspect in the form of calculating calorific value, fuel requirement, and boiler performance. And the second one is economic aspect, is in the form of financial analysis of the use of wood base as a fuel. And the last one is the environmental aspect, is analysis of amount emissions from burning the use of wood base. The first one, technical analysis. Technical aspect analysis is carried out by analyzing the heat required by the boiler and amount of fuel required. Calculation of the calorific value resulting from burning wood base is compared with the calorific value resulting from burning diesel fuel, so that the amount of fuel needed to meet the boiler's heat requirements can be determined. Based on the specification of boiler machine at PT Putra Al-Basyah Mandiri uses as a pressure of only 6 bar and requires an average steam rate of 6 tons per hour. The fuel used is wood base resulting from the production process, with the main use being sawdust and wood chips as supporting fuels. The boiler heat requirements are calculated using this formula. And the equation above, the superheated steam enthalpy value and the feed water enthalpy value entering the boiler are known from the saturated water and steam pressure tables namely the superheated enthalpy value, Hg is 2755.5 kilojoule per kilograms, and the feed water enthalpy HF is 670.4 kilojoule per kilogram. Fuel requirements are calculated using this formula. The calorific value of two types of fuel will greatly influence the result of calculation the fuel requirements needed to meet the boiler's heat requirements. The boiler works 24 hours a day, so the amount of boiler's fuel consumption is calculated per year. Fuel consumption is calculated as follows. The next parameter in boiler performance analysis is amount of heat produced by combustion, which aims to find out how much heat is produced from how much fuel is used. The calculated using the volume formula. The final parameter in the boiler performance analysis is boiler thermal efficiency, which aims to determine the efficiency of boiler, calculated using the volume formula. The second one is economic analysis. Analysis of economic aspect is the form of financial analysis is carried out by projecting fuel costs for diesel boilers, describes the feasibility level of investment in a boiler machine for a period of 10 years. Indicators used in the financial feasibility aspect include NPV or net present value, fuel cost profit value, boiler's operational requirements, and boiler's investment value. NPV is a calculation method that uses the present value principle by finding the difference between the initial project investment and total net cash flow value over the life of the project. If the NPV calculation result is positive, then the project is concluded to be feasible. The NPV calculation can be found using this formula. The next one is environmental analysis. Environmental aspect analysis consists of analyzing the relationship between the environment and the combustion result of, or the amount of combustion emission from using wood waste as fuel and comparing it with the diesel fuel. Heat and exhaust gases are result of the burning fuel. Heat is used for oven process while exhaust gas is released into the air. Carbon emission or carbon dioxide are one of the most exhaust gases produced from the combustion. The amount of combustion emission can be determined from the emission factor, which is the average value of air pollution parameter released from specific source. Carbon dioxide gas, if released into the air in excess, can have a bad impact to the environment. Calculation of amount of emission carbon dioxide can be a measure of the amount of pollution contributed boiler combustion. The following is a calculation of determined emission level of carbon dioxide compound from combustion process based on guidelines for calculating and reporting greenhouse gas inventories. Directorate General of Electricity, Ministry of Energy and Mineral Resource in 2018. This one. And comes to the last one, result in discussion. Calculation of calorific value, high calorific value of combustion, low calorific value of combustion, financial feasibility analysis, and the last one is analysis of total carbon emission. For the calculation of calorific value, as the effort of determine the heat requirements of the boiler machine with an average steam rate requirements of 6 tons per hour, boiler's constant pressure data of 6 bar is used. The results of searching for enthalpy value of saturated water and steam pressure tables are superheated enthalpy value of 2755.5 kilojoule per kilogram, and the with water enthalpy HF is 670.4 kilojoule per kilogram. The calculation of boiler heat requirements is as follows. So the result is 12,510,600 kilojoule per hour. And this is the high calorific value of combustion as much as 148,321.41 kilojoule per kilogram. And the low calorific value of combustion is as much as 145,881.41 kilojoule per kilogram. The calculation of low combustion heating value of diesel value as 41,640.65 kilojoule per kilogram. And wood-based fuel requirement is 0.086 meter cubic per hour, while diesel fuel requirement is 255.37 liter per hour. The amount of heat resulting from burning wood waste is as much as 145,081,410 kilojoule, and the amount of heat resulting from burning diesel fuel is 41,640,660 kilojoule per kilogram. Efficiency of wood-based fuel boilers is 20.12%, while efficiency of boilers using diesel fuel is 70.1%. NPV, or net present value, as much as 4,653,186,775.23 rupiah. Analysis of total carbon emission. Environment analysis is carried out by finding out the relationship between the environment and the boiler engine fuel combustion process. The calculating amount of emission carbon dioxide from burning wood waste and diesel is 1 year. In 1 year, I mean. It is known from the result of low heating value calculation that LHV value of wood-based fuel is 145,081.41 kilojoule per kilogram, while LHV value of diesel fuel is 41,640,040.66 kilojoule per kilogram. Based on the result of calculating fuel needs, wood-based fuel consumption in 1 year is 743.04 meter cubic, or 74,304 kilogram, and diesel fuel consumption in 1 year is 2,206,396.8 liter, or 1,875,437.28 kilograms. Based on data, the emission factor of burning wood waste is 112,000 kilogram carbon dioxide per terajoule, and diesel burning factor is 74,100 kilogram carbon dioxide per terajoule. Calculation of emission carbon dioxide from boiler consumption in 1 year is as follows, where 1 terajoule is equal to 10 power of 9 kilojoules. This is the DA wood waste, and this is the DA diesel fuel. This is emission of wood waste, and this is the emission of diesel fuel. Conclusion: to meet the heat requirement of the boiler, it is necessary to consume more diesel fuel than consume wood-based fuel due to the low combustion calorific value, or LHV, of wood waste. The cost of wood-based fuel is smaller than diesel because the wood-based fuel comes from production waste. So the cost of wood-based fuel is considered a profit. Financially, a wood-based fuel boiler machine can be declared worthy of investment. And the last one, using wood-based fuel produce lower carbon emission than carbon emission from burning diesel fuels. Using wood waste as fuel can reduce the use of fuel oil, which is non-renewable renewable fuel, and as an effort of controlling production waste. Thank you for the time and attention. Assalamualaikum warahmatullahi wabarakatuh. 1.